Welcome to Planet Earth, Our Loving Home. Today's episode is entitled Vegan, the Fastest Way to a Cooler Planet, Part 3. During this series, we will introduce you to current information on greenhouse gas emissions, solutions for rapid planetary cooling, and why a plant-based diet is the quickest, most inexpensive way to reduce emissions and stabilize the Earth's temperature. In the past, efforts to mitigate global warming have focused almost exclusively on lowering carbon dioxide emissions. But we now know that although reducing CO2 is critical, even if the entire world switched to a zero-carbon economy and lifestyle today, it would take thousands of years for this gas to dissipate. Some scientists and government officials now recognize that limiting shorter-lived greenhouse gases such as methane and ozone and other contributors to warming such as black carbon, released into the air from burning biomass and fossil fuels, can have a major influence in slowing planetary heating in a short amount of time. As one climate scientist says, we need to reduce short-lived greenhouse gases today in order to ensure a livable planet for our children. And we need to reduce CO2 to ensure a livable planet for generations a few hundred years from now. Limiting these gases, particularly methane, is relatively inexpensive and rapid, whereas many of the technologies to reduce CO2 are either in their infancy or are costly and time-consuming to integrate into the current infrastructure. Scientific understanding of the role of livestock in accelerating global warming has increased as well. Some researchers are beginning to recognize that livestock contributes much more to global greenhouse gas emissions than the 18% estimated by the 2006 United Nations Food and Agricultural Organization report, Livestock's Long Shadow. Demand for beef directly contributes to the rapid melting of Antarctica due to the black carbon and other pollutants emitted into the atmosphere by livestock raising. Dr. James Hansen, one of the world's preeminent climate scientists, recently stated that if Western Antarctica melts, it could be one of the most frightening climate change tipping points of the 21st century.
What we're concerned about is bigger tipping points, ones which are not reversible on any time scale that's of interest to humans. For example, the ice sheets on West Antarctica and Greenland. If those begin to disintegrate and slide into the ocean, then that's irreversible on time scale less than tens of thousands of years. You can reduce the greenhouse gases, but it's not going to stop that ice sheet. We don't want to get to a point of no return. I don't think we are there yet, but in the case of the ice sheets, we may be getting close.
Today, parts of Antarctica, such as the Wilkins Ice Shelf, are melting at a frightening pace, thus contributing to rising sea levels. At the March 2009 meeting of the International Scientific Congress on Climate Change in Copenhagen, Denmark, participants projected that if immediate action is not taken to address climate change, sea levels could rise more than a meter by century's end, displacing over 600 million people around the globe. Recent studies by scientists from the United States National Aeronautics and Space Administration, NASA, have found that pollutants such as black carbon have a much greater effect on climate change than previously thought. Also, Brazilian research indicates that South American agricultural practices, particularly biomass burning for livestock production in central Brazil, are the source of most of the black carbon found in the Antarctic Peninsula. Thus, we can see how cattle raising plays a significant role in the rapid warming of Antarctica and, in turn, our planet as a whole.
Methane is like carbon on steroids. It's dozens of times worse than CO2. And then black carbon is hundreds of times worse.
Meeting of the committee will please come to order. Today's hearing will focus on the issue of black carbon and global warming. Black carbon is commonly known as soot. Dr. Bond, I'd like to hear from you.
Chairman Waxman, Ranking Member Davis, and members of the committee, I've spent the last 12 years modeling and measuring sources of black carbon, and I'm pleased to share my expertise about the role of black carbon in climate change.
It is like anything black. It absorbs sunlight and turns it into heat. You can feel that happening when you walk across a hot parking lot on a sunny day. It will take sunlight and turn it into heat, warm the atmosphere, or if it's sitting on snow, it'll melt the snow.
When we return, we will have more about black carbon and its devastating effects on our planet. You're watching Supreme Master Television. Welcome back to Vegan, the fastest way to cool the planet, on planet Earth, our loving home. We will now continue examining black carbon's effect on climate change.
Well, black carbon comes out from basically inefficient combustion. And so if you have an inefficient engine, it'll put out little black particles, which some people call soot, some call black carbon. They get into the atmosphere, they can get blown by the winds, and they get deposited into areas where there's snowing and glaciers, and it will increase the absorption of solar radiation there, and that'll create warming that tends to melt the ice and the snow.
Our best guess of the sources of black carbon is there's quite a lot from open burning of forests and savannas. It's about 40 to 50% of the global emissions. There's about 20 to 25% from household combustion of solid fuel, so that would be people cooking with wood and coal. And there's about 20 to 25% from diesel engines. There's a small contribution from industry, particularly in countries where the technology is not as strong and emission controls are not in place.
Another interesting and complicated part of the problem is what does happen to the soot once it lands on the snow. If you think about it, the snow starting to melt, you would think that they would get washed down through the snow layer with the water and disappear. There's some indication that the black carbon particles don't absorb water. They're what we call hydrophobic, so that when the snow starts to melt, they're actually left behind on the surface of the snow, which would make their impact even stronger because you would have a concentration of the black particles at the surface. And so in that sense, you may have an amplification of the effect, and it would basically continue to affect the reflectivity of the snow and how warm it gets for as long as it sits up at the surface.
Can you tell us what the global warming potential is of black carbon?
The global warming potential of black carbon over 100 years is about 680. That means that for 1 pound of black carbon put in the atmosphere, you get 680 times as much energy added to the atmosphere as if you put in a pound of CO2.
Supreme Master Television interviewed Brazilian researchers via email to learn more about their studies of black carbon's role in melting Antarctica's hotspots, and learned that although the research is still in its infancy, they have found links between Latin America's livestock industry and this process. Dr. Heitor Evangelista, Deputy Head of Department of Biophysics and Biometry at the State University of Rio de Janeiro in Brazil, stated,
"We have measured from the South Atlantic, or Rio de Janeiro, Brazil, to the Antarctic Peninsula over several years. Black carbon has been detected in several stations around Antarctica and at the South Pole. Higher values are found in the Antarctic Peninsula, probably due to the shorter distance to South America. But a similar process as that observed in Greenland was not already observed, not because it had never occurred, but because very few experiments were conducted. Also, we have modeled the dispersion of black carbon to Antarctica, and we have concluded that around 60% of the black carbon measured at the Antarctic Peninsula derives from South America, mainly events of biomass burning in central Brazil. The largest amount of biomass burning in South America occurs in Brazil. It is not only due to deforestation, but also from pasture regions and sugarcane plantations. People deforest, remove commercial wood, and put fire to the rest. Paraguay, northern Argentina, and Bolivia also contribute to that. Also, around 30% of the black carbon apportioning in the Antarctic Peninsula comes from Africa, and we do not have much data on these emissions.
The nonprofit environmental group Greenpeace International estimates that 80% of the Brazilian Amazon rainforest area destroyed between 1996 and 2006 was used to create pasture for cattle grazing. Professor John Broder, author of Rainforest Cities, Urbanization, Development, and Globalization of the Brazilian Amazon, and professor of urban planning at Virginia Tech University in the USA, spoke with Supreme Master Television on the role of livestock production in destroying the Amazon region.
What is driving deforestation now in the Amazon are three things. And first and most important is the expansion of the livestock sector over the past 10 years. And by livestock, I mean beef cattle industry. And I, for years, have been trying to figure out a mathematical model for predicting change, and I finally come up with a very simple one, that deforestation rates are going to be high. They're going to depend on two things. One, the price of beef products in the European market times the population density of the municipio in the producing supply region. We have not tested that, but it really comes down to basically beef and how much available forest lands within proximity of a transport node. Two other drivers that I had, apart from cattle, is soybeans, and after that, sugarcane. But what the corporations are sometimes doing is alternating between pasture and soybeans. Soy is a legume. It fixes nitrogen in the soils that are sometimes converted then to pasture and heavily used for that purpose.
Where does the burning of the biomass come into the agricultural production cycle there?
Well, to clear forest, you have to cut it down, and then you have to let it dry, and then you burn it. So in the southwestern Amazon, southern Amazon, most deforestation occurs at the end of the rainy season, which is April, May, about this time. The cut slash is left on the ground through the dry season from about this time to when the rainy season resumes. During that time, the slash dries and then it's burned on the ground starting in August, which is called the burning season. So I've experienced some unbelievable forest slash burning events in my field work in the Amazon. Routinely, the national airport at Porto Velho, the capital city of Rondônia, during the burning season is closed because visibility does not permit landings and takeoffs. It's been so thick that you would think that you would need a ventilator outside to breathe. It's been so thick that you would think it was the middle of the night because it's blocking out the sun even though it's high noon.
Is it burned off once a year, or is it just whenever they're doing new deforestation?
Areas that have been cleared of primary forest but then abandoned after several years, and there's regrowth. A lot of the forest burning is from secondary forest. Probably most of it is, I would say, rather than primary forest at this point.
Thank you for your time today as we learned about the links between global demand for meat, the creation of black carbon, and the melting of Antarctica. We look forward to seeing you again next week for the final episode in our series, Vegan, the fastest way to a cooler planet. Please stay tuned for enlightening entertainment coming up after noteworthy news here on Supreme Master Television. May all people be as one in our shared effort to save our planet.
For more details, please visit www.suprememastertv.com/PE.